Let's learn about properties of orthogonal matrices. Okay. So the first property is that if A is an orthogonal matrix, then determinant of A will be equal to plus minus 1. This is the first property of orthogonal matrices. Okay. Now, if A is an orthogonal matrix, it is given that A is orthogonal and we have to prove that determinant of A is equal to plus minus 1. This is what we have to prove. Now, A is orthogonal matrix. So, by the definition of orthogonal matrix, A transpose will be equal to I and it will be equal to A transpose A. That is multiplication of A with A transpose will be commutative to multiplication of A transpose with A, and that will yield you an identity matrix. Now, let us consider this particular fact. Okay, this from here till here. Let us consider this much only. For the time being, let us consider this much only. Forget about this. Okay, consider this much only and forget about this. Then what will happen? Consider A transpose is equal to I, that is identity matrix. A transpose is equal to I, that is identity matrix. Take the determinant on both the sides. What we are doing is that we are taking the determinant operator on both the sides. So determinant operator on the left side, it has been written like this, and determinant operator on the right side, it has been written like this. Now, determinant of identity matrix is equal to 1. So determinant of identity matrix has been replaced with 1, and determinant of A transpose can be written as determinant of A multiplied by determinant of A transpose. How? By this particular property. Determinant of AB is equal to determinant of A into determinant of B. Okay, determinant of AB is equal to what? Determinant of A into determinant of B. So similarly, determinant of A transpose will be equal to determinant of A into determinant of A transpose, and determinant of identity matrix is equal to 1. That has been written. But we know this very well that determinant of A transpose will be equal to what? Determinant of A transpose will be equal to determinant of A. Okay, determinant of A transpose is equal to determinant of A. Okay, so we will replace this determinant of A transpose. With what? With determinant of A. Okay, so that determinant of A transpose has been replaced by determinant of A. So it came out to be determinant of A into determinant of A is equal to plus 1. Okay. Now let us assume that determinant of A is equal to x. Let us assume that determinant of A is equal to x. Let us assume. Then what will happen? This will be replaced by x, so x. This will be replaced by x, so x, and 1 as it is. So x into x is equal to 1. X into x is x square, so x square is equal to 1. Take a square root on both the side. What will you get? X is equal to plus minus 1. Okay. Square root of 1 is plus minus 1, so that's why x is equal to plus minus 1. But x is equal to what? X is equal to determinant of A. So that's why this x will be replaced by determinant of A. So determinant of A came out to be equal to plus minus 1. Okay, this is write it properly. Just a second. Okay, write it properly like this. Okay, the symbol has not been written properly. Okay, plus minus 1. Okay, like this. So this is the determinant of A came out to be equal to what? Determinant of A came out to be equal to plus minus 1. Okay, now we know that if a matrix is orthogonal, we have successfully proved that if a matrix is orthogonal matrix, then its determinant will be equal to plus 1 or minus 1. Okay, for every orthogonal matrix, its determinant will be plus minus 1. But the converse is not true. This is very important fact. This particular fact is very important. Okay, keep this thing in mind. This particular fact is very important. Converse is not true. Which converse is not true? The thing is that if a matrix is orthogonal, its determinant will be plus minus 1. Okay, if matrix is orthogonal, then its determinant will be plus minus 1. But if the determinant of a matrix is plus minus 1, if suppose the determinant of a matrix is plus minus 1, then it does not imply that the matrix is orthogonal. Okay, so if the matrix is orthogonal, then determinant will be plus minus 1. But if determinant is plus minus 1, then it is not necessary that the matrix will be orthogonal. Okay, so converse is not true. Keep this thing in mind. Very important fact. This fact is very important fact, because this is the point where students get confused. Okay, converse is not true. Keep this thing in mind. If the determinant is plus minus 1, we cannot say necessarily that the matrix is orthogonal. Okay, but if the matrix is orthogonal, this is given, then certainly determinant will be plus minus 1. But if determinant is plus minus 1, then we cannot say whether matrix is orthogonal or not. We cannot surely say matrix is orthogonal. We cannot surely say that matrix is orthogonal if determinant of A is equal to plus minus 1 is given. Okay, so keep this thing in mind. Thank you very much.